We've learned to recognize monosaccharides by numbers of carbons, by aldehyde or ketone, by D or L, and by alpha or beta. So now what we're going to do is we're going to classify these differences. All this chirality gives us isomers, stereoisomers. And so this has 4 chiral carbons. And remember, an enantiomer is the mirror image, a non-superimposable mirror image. We have 4 chiral carbons, so that the mirror image is going to be non-superimposable. D-glucose's mirror image, L-glucose, you can see these are enantiomers, mirror images, non-superimposable. We call this L-glucose. This L-glucose is not found in nature. We can synthesize it in the lab, but we won't find it in nature, and it's not biologically useful. It would pass through your body probably totally unabsorbed, or maybe absorbed and then released without being modified, because your enzymes are specifically built to take just D-glucose. So what do you do to classify things as enantiomers? You make sure all the functional groups are the same, all the numbers of carbons are the same, and then verify there's a chiral carbon, at least one, and that it is a mirror image. If we look at these two, you can see this is D-glucose, and this is something called D-galactose. Same number of carbons, same functional groups. The only difference is, look, hydroxyl's on the right, left, left, right. But here it's right, left, right, right. This carbon right here has a different stereochemistry. Everything else is the same. When you have just one carbon in which the stereochemistry is flipped, we call them epimers. There are a lot of epimers with the hexoses and the pentoses because there's so many chiral carbons. For instance, with the aldohexoses, you have 8 different epimers because the chirality can be flipped at each one of these carbons. Okay, so epimers, you look for one carbon having a different stereochemistry. Everything else is the same. Then we have the alpha and beta isomers that we call anomers. This carbon that is all the way over on the right, we call the anomeric carbon, and the hydroxyl group can be down for alpha or up for beta. And so you just look for alpha or beta. Everything else has to be the same. 6 carbons, everything else is the same, the chirality. Okay, so what kind of isomer are these? Well, we look and we see all of the carbons are exactly the same except for these 2. So those are epimers. And what type of isomers are these? Well, if we look, we can see they have all the functional groups are the same, but on the chirality, they're exactly the opposite. These are mirror images, and they're non-superimposable because of the chirality. So these are enantiomers.